Somewhere on the other side of the planet, a stranger is standing in a queue. You will never meet them. You share no language, no country, no single memory. And yet, if you could follow both of your family trees backwards, far enough and carefully enough, they would collide. And not in the distant fog of prehistory. Recently. Uncomfortably recently. Start with something simple. You have 2 parents, 4 grandparents, 8 great-grandparents. Every step backwards doubles the number of people required to produce you. And that doubling gets out of hand faster than almost anyone expects. Go back 10 generations, roughly 3 centuries, and your tree needs 1,024 ancestors. Go back 20, and it needs over 1 million. Go back 30 generations, around 900 years, an age of stone castles and no printing press, and the number of slots in your family tree passes 1 billion. Do you see the problem? There were nowhere near 1 billion people alive on Earth back then. The arithmetic has broken. Except it hasn't. Those slots are real. What's wrong is your quiet assumption that each slot holds a different person. It doesn't. The same individuals show up in your ancestry again and again, filling hundreds, thousands, sometimes millions of positions at once. Because somewhere upstream, your mother's line and your father's line were already the same line. Genealogists call this pedigree collapse. It is not a strange quirk of inbred royal families. It is the ordinary condition of every human being who has ever existed, including you. So your family tree isn't a tree, it's a net. And here's the question that changes everything. If every person alive is dragging a net backwards through time, how long before all those nets tangle into one? In 1999, a statistician at Yale named Joseph Chang decided to actually calculate it. He built a deliberately simplified model, a population where everyone could pair with anyone, no oceans, no borders, no distance at all, and asked how many generations you'd need before a single individual appears in the ancestry of every living person. The answer was startling. Not 1 million years, not 100,000. In his idealized model, the most recent common ancestor of everyone sits only around 30-something generations back. Now, that model is obviously unrealistic. Real humans do not mate at random across the planet. Mountains matter, oceans matter, language, religion, and geography all matter enormously. So in 2004, Chang teamed up with Douglas Rohde and Steve Olson and published a much harder version in the journal Nature. This time they built a simulated Earth with real continents, real ports, real migration routes, and deliberately stingy assumptions about how often anyone moved. And the tangling still happened. Their models placed the most recent common ancestor of everyone alive today only a few thousand years ago, in their more conservative run, somewhere in the 2nd millennium before the Common Era. Think about what that means. When the pyramids were already ancient, a person was alive whose descendants now include you, and the stranger in that queue, and every human being currently breathing. Why doesn't isolation stop this? Because the barrier is much weaker than it looks. A population does not need constant contact to be swept into the global family. It needs one. One sailor blown off course. One trader crossing a mountain pass and never going home. One marriage between neighboring valleys, once a generation, is enough to stitch a group permanently into everyone else's ancestry. Because that single thread then multiplies through every descendant that follows. Isolation delays the merge. It almost never prevents it. And the researchers found something even stranger waiting further back. Push past the common ancestor and you reach a point they called the identical ancestors point, where the ancestry of humanity stops being partial and becomes total. Before that line, every single person who was alive and who left any surviving descendants at all is an ancestor of every single person alive today. Not most. Everyone. Their models put that boundary only about 5,000 to 7,000 years ago. Everyone before it who has descendants is in your family. Everyone else's family tree ends there. There are only 2 categories that deep in time: your ancestors and dead ends. Now, an honest caveat, because the science here has a sharp edge. Being someone's genealogical descendant does not guarantee you carry their DNA. Your genome is shuffled and cut every generation, And after roughly 10 generations, most of the people in your tree contributed no measurable genetic material to you at all. They are your ancestors. Their DNA simply didn't make the journey. So this is a claim about family, not about genes, although genes tell a related story. In 2013, Peter Ralph and Graham Coop published a study in PLOS Biology examining DNA from across Europe, comparing long shared stretches of chromosome between people from different countries. They found that individuals separated by 1,000 kilometers still share large numbers of genetic common ancestors within the last 1,000 years or so, not symbolic ancestors, traceable ones written into living chromosomes. This is why claims that once sounded absurd turn out to be mathematically boring. If you have any European ancestry, you almost certainly descend from Charlemagne, along with essentially everyone else who does. The same logic applies to ordinary people you'll never hear about, the vast majority who left no monuments at all. It also means something uncomfortable. Whoever you imagine your people to be, the line you drew is far too small. Every empire and every group it conquered, both sides of every ancient war, the invaders and the invaded, the enslaved and the enslavers, are all sitting in the same family tree. And it's yours. There is no branch of humanity you're not attached to. There is no group whose story isn't partly your inheritance. Ancestry, it turns out, is not a stack of separate towers. It's a single fabric, and everyone alive is threaded through it. And the timescale is what makes it land. 3,000 years is not deep time. It is about 100 grandmothers, each one holding the hand of the next, standing in a line you could walk down in an afternoon. That's the entire distance between you and the person who belongs to all of us. So look again at that stranger on the other side of the planet, still standing in that queue. Nothing about them has changed, only what you know has. They are not a stranger you happen to share a species with. They are your cousin taking the long way round, on their way back to the same family you came from.